want to switch it, right? If I go 1 minus 4, that's negative 3, but I always want to express with positive variable exponents. So I always want to use positive exponents in the end. So if you had written negative 3, now you can see why you don't need the 1. So this is the same thing as 1 times that is x to the 7th over 3y to the 3rd. Any questions on that? Dividing a mono. This is basically just reducing a monomial divided by a monomial. Okay, let's look at this one. This is the one, I want you to star this one. You will see this probably on a test. You will see this problem. And I will tell you that in most math classes, students get it wrong. Because what they want to do is you want to cancel these, don't you? But you absolutely cannot. And let me explain why that is, because this is an important point. Okay, if I had the fraction 10 over 11, could I reduce the fraction 10 over 11? How many people are absolutely certain I cannot reduce it? Okay, you're right, I cannot reduce it. But I want to show you that 10 is the same thing, 10 over 11 is the same thing as 10 plus 1, isn't it? Is 11. Can I just cancel those 10s? No, I can't, because if I did that, this would be wrong. I would have, if I canceled it, what would I have? Would I have 1/2? I would have 0. Well, if I cancel, there become 1, right? 10 divided by 10 is 1. So are you telling me that 10 elevenths is equal to 1/2? You see, if people cancel the 10s, they would have 1 over 1 plus 1, which would be 1/2. But we all know that 10 elevenths is not equal to 1/2. So you have to be really careful that when you're reducing, everything when you reduce has to be factored. It has to be multiplied. Okay, so if we look at this, you cannot cancel those x plus h. You would have to first distribute here the negative, and there's nothing to distribute here. So if I simplify this, I have 50x plus 50h plus 35. And then what happens when you distribute the negative? Yes, minus 50x minus 35. You see that? That's distributing the negative over x plus h. There was a 1 out in front, so I didn't really need to distribute anything. I could multiply by 1. It stays the same. Minus x. Okay, that's step 1. We want to simplify this whole entire numerator and simplify the whole entire denominator. So is there anything in the numerator that can simplify? Yes, the 50x minus the 50x is 0. Anything else? 35 minus 35 is 0. So what are we left with in the numerator? 50h over, what simplifies in the denominator? Yeah, the x's cancel because x minus x is 0. We're left with h. And now 50h divided by h, what's h divided by h? 1. So what do we get? 50. Excellent. Okay, now these ones, the reason why I brought up that thing about how you're not able to cancel those, because of the addition, here you have to factor first. So always remember that you have to factor. You cannot divide over subtraction. So how would you factor the numerator? What's the GCF of the numerator? 3 goes into both, so we factor out a 3, we get 2 minus x, right? And then what about the denominator? How would you factor it? So you'd have x times x gives you x squared plus or minus 2, right? Now, what we're looking for is something to be a perfect match, just like when we reduced 15/25, we looked for something that was an exact match. Is there anything that matches completely that would divide out to become 1? X minus 2, but see how this is 2 minus x? They're exactly the same, but this 2 is positive and this x is negative, right? So when we reduce these, we cancel them. We can go back to this rule, which says that if I cancel those, what do they reduce down to? -1. So let's give this negative time to the 3. -3, because -1, this would cancel the -1. -1 times 3 is -3 over x plus 2. That's how that would reduce. Okay? Now let's try this one. Always start with number 1 rule of factoring is look for a GCF. There you go. What's the GCF of the numerator? 5 and x. Good. And so what would be left if you factor out a 5x? X minus 2. Great. What about in the denominator? You see where the factoring is coming in super handy now. How would you factor the denominator? X and x gives you x squared. You're looking for two numbers that multiply to -6 and add to 1. Can anyone think of what those numbers would be? Yes, 3 and 2. Tell me about the signs. Yes, -2 plus 3. And then you see here, cancel. Why do these cancel? Well, because x minus 2 divided by x minus 2 equals 1. Anything divided by itself when it comes to a fraction is 1. Here we had 2 minus x over x minus 2. That equals -1. So that's the difference there. It's just about the order. Okay. So what are we left with once we cancel those? X plus 3. Okay, and by the way, we would still want to retain the idea that that canceled, but x still cannot equal 2. If we plugged in x equals 2 there, then it's going to still give us 0, even though those canceled out. So you don't see them in as part of the domain, but we're going to get to domain once we get to the graphs as well. Yes, question? Oh, that is a really good question. Okay, so this is the question. I'm so glad you asked that before I push stop. He wants to know, can we cancel these x's? What do you guys think about that? We can't, and why can't we? The 5 is being multiplied by the x. That would have been fine, but here the x is plus 3. So let me try and think of an example that would make more sense without variables. Let's see here. Okay, let's say that the x was 1, okay? If the x was 1, I would have 5 times 1 over 1 plus 3, which is 5/4. Can you reduce the fraction 5/4? So what happened is this x is a placeholder for any number. And when we're reducing like that, we want to make sure that that would stay true for all values of x. Does that kind of help a little bit as to why? Okay, and so anytime if you're stuck with that question, you're like, can I reduce? You could try different values for x to see if it really made sense. Everything that reduces has to be multiplied. It has to be factored. We can never cancel over addition, and that was basically back to that problem about why we were all convinced that you couldn't reduce 10/11ths, but then I broke it down into an addition problem and showed how they wouldn't be equivalent, you know? Okay. All right. So I'm going to stop it there and we're going to try some group work.